MzeroA Nation, Jason here. Welcome into day 27 now of the 31-day Safer Pilot Challenge. What a blessing it is that you made it this far. How outstanding. Go back and look at the views. I'm telling you, days 1, 2, and 3, they have all the views. And they kind of trickle down from here. Maybe one or two kind of went viral and spiked a little bit, a few other ones. But as far as those of you who've made it this far in the challenge, you are few and far between, especially watching a video about top of climb and top of descent. Not exactly the most riveting topic, but it's necessary because it bothers me so deeply when student pilots fail to calculate top of climb and top of descent. So often we just say, hey, I'm going from here to here, and we grab the winds aloft and we just use that for our ground speed the entire time. When we can't really do that, because there's takeoff and there's winds at the surface we can use. We need to interpolate through from the METAR to the 3,000 foot winds aloft and above and work through those as we climb through. Because the winds at the surface and even the winds at 3,000 feet, rarely are they ever the same. We have to do something called interpolate. Let me share with you quickly a very simple way to calculate top of climb, and then top of descent, we just reverse engineer this formula. Let's say we're doing this cross country here. We're going from Ocala down here at the bottom of your screen over to Cross City at the top of your screen. Looks like a 307 heading, 54 nautical miles. I teach it the following way. To calculate top of climb, we need to answer really three simple questions. First off, what altitude? Okay, we're heading west. West is best, plus 500, so an even altitude plus 500. Let's do 4,500 feet. Now, I know my VY climb of 80 puts me at about 500 feet per minute. So 4,500 feet, and by the way, AGL and MSL, this is the ocean right here, the Gulf of Mexico. AGL and MSL are about the same, as you can see here. I mean, we don't have any high elevations out where we're at. So AGL and MSL essentially the same for this case. So 4,500 feet, that's where I'm going to, at 500 feet per minute. I'm doing the division on that, means it's gonna take me 9 minutes to get up there. But 9 minutes at what ground speed? Well, to solve that, we need to do what's called some interpolation of our ground speed. Because I can look at the METAR for Ocala and go, okay, the winds at the surface are 050 at 7. That's awesome. I can then pull the winds aloft at 3,000 feet for Tallahassee, which is continuing to the northwest here. And at Tallahassee, there's 090 at 11, at 11 knots. I can average between the two. 050 and 090, let's just call it 070 as the direction. 070 as a velocity and 11 as a velocity, let's average between the two and call it 9. So if we average between the two, we'll just say the winds are 070 at 9er, because from the surface all the way on up, we're just going to work through that interpolation. So now we ask ourselves the question, we come to the E6B. While flying a course of 307 with a true airspeed of 80, because 80 is my VY climb that gives me 500 feet per minute, the winds are from 070 at 9er, what's my heading, ground speed, and wind correction angle? Well, I learned my ground speed is going to be 85. I can then get my wind correction angle, my heading, and everything else I need. But for the sake of top of climb, I just really need my ground speed of 85. So now I ask the question, at 85 knots, how far will I travel in 9 minutes? So I come to my E6B and I just reverse engineer it. I'm traveling 85 knots, I know now, for 9 minutes. How far will I go? How many miles? Okay, I'll go, I'm just making this up now. Let's just say I'll go 10 miles. I then measure from Ocala 10 miles out and go, oh, okay, that's gonna put me over this Crosswinds private airport here. That then becomes my top of climb. Top of descent works the same way, but a little slightly different, because top of descent, I'm actually planning down to pattern altitude. So from 4,500 feet down to 1,000 feet. AGL, MSL, again, about the same thing to get down to pattern altitude. Okay, 3,500 feet is what I need to lose at a 500 foot per minute descent at 80 knots, interpolate from the winds aloft on down all the way to close to the METAR, do some interpolation, do the division, and I can calculate top of descent working backwards as well, measuring from Cross City out to know where I need to start my top of descent. We can't afford to neglect top of descent and top of climb. It's an essential part of your flight planning. Hey, I know the G1000 does this, by the way. I know ForeFlight helps you. I know there's amazing tools out there that show you how to do this. But on your check ride, you're gonna need to know the old-fashioned way, just like this, to calculate top of climb and top of descent. Can't wait to read your comments below this video. Hope you've already pre-ordered your copy of Aviation Mastery, the book. Aviationmastery.com, taking my 10,000 hours of flight experience, compiling it into about 200 pages and plus in there as well. Have a blessed, amazing rest of your day, and most importantly, remember that a good pilot is always learning. We'll see you.